welcome back to my channel. So we are actually in part 2 for the valence bond theory. So in this part 2 we will discuss, or we will learn about how to determine the hybrid orbitals for the square planar and also tetrahedral. So let's start. Before that, let's recap back, okay, the difference between valence bond theory and also the crystal field theory. So don't worry too much. The crystal field theory we will learn about this CFSE or CFT next week. So for the valence bond theory, it will give you or you can determine the hybridization of the tetrahedral, the octahedral, and also square planar. So if you have the tetrahedral geometry, you will have the sp3 hybridization, and if you have octahedral geometry, you will have two different hybridization, whether they are D2 sp3 or sp3 D2, and also last but not least, square planar dsp2. And in this part, as I mentioned before, we will discuss about the tetrahedral and also square planar. And for the crystal field theory, let me give you a little bit or a briefing a bit about CFSE. So in CFSE, we will focus on low spin and also high spin complexes, and also the types of ligand. Right, then for the first one, here we have the tetrahedral geometry, where you have the sp3 hybridization. The sp3 hybridization here. This is where we have the overlapping between S and also P orbital. We have the tetrachlorocobaltate. Okay, so the oxidation state for this cobalt is, let's find the oxidation state. So this is X, this is -4 equals to -2. So this is X equal to +2. So this is actually tetrachlorocobaltate 2. Tetrachlorocobaltate 2, where the proton number or the atomic number for cobalt is 27. Right, 27, and then here the electron configuration for cobalt is Ar 4s2 3d7. So 18 plus 2 plus 7 is 27, and then we need to have the cobalt 2 plus. So the electron configuration for cobalt is Ar 3d7. Okay, then here this cobalt 2 has 3 ampere electrons. Has 3 ampere electron, which makes it paramagnetic and attracted by magnets. And then, okay, how to determine these 3 ampere electrons? So you have the 3d7. Let me draw to you the orbitals. Okay, so you just need to show the d orbital, only the d orbital. So we have 5 d orbital. So the 3d7 you need to fill up singly. 1, 2, 3, 4, 5, 6, and also 7. So this is the 3 ampere electron. Right, 3 ampere electron. So this compound is actually a paramagnetic. Okay. Then if you have the, after the 3d, you're gonna have the 4s and also 4p. Right. So this is just the free ion. Okay, the free ion. Then you react this cobalt 2 with chloride, 4 chlorine here, and you get the tetrachlorocobaltate, okay, 2. Right, so as you know, this is the structure for the chloride. This chloride is a ligand, is a monodentate ligand, okay, because it has a lone pair, right? So here, because we have 4 chloride, it means that this chloride share 4 lone pair. So means 4 times 2, it will give you 8 electron. And then, so what happened here? After the 4s, and also the 4, after the 3D and then followed by 4s and also 4p, this, okay, because each of these will give you 2 electron. So if we have 4, it will give you 8 electron. Because this is a paramagnetic and attracted by magnets, you need to fill up all these 8 electrons, start from the s orbital and followed by the p orbital. So this is actually from one chloride, and then this is from the second, third, and also fourth. So from this one, okay, you have a new orbital, or what we call hybrid orbital of sp3 s, this is s, and also 3p, p3. So the 4 sp3 bonds to the ligand. So the structure for this complex is here, and then you have chloride here, 4 chloride with the negative 2. So this is a cobaltic, right? So you have coordination number of 4. Yeah, that's how you determine the tetrahedral geometry, sp3 hybridization. And then here I have a second example here. We also have tetrahedral sp3 for zinc. This is tetrahydroxo zinc. Okay, let's look at the oxidation state for this zinc. Zinc is 30, the atomic number is 30. And then here we have negative 4 equals to negative 2 and x. So your x is positive 2. So this one is Ar, 4s2, 3d10. You want to have the zinc 2 plus. So this one will give you as Ar 3d10. Okay, alright. And then as you know, OH minus with also lone pair at the oxygen here. So this is actually a donor or ligand. So you draw first the 3d10, the d orbital here we have 10. In this case, for this compound, it is actually a diamagnetic compound, right? Diamagnetic compound. And then we have 4 hydroxide here, so it will give you 8 electron. So you cannot fill up here, alright? You cannot fill up here. So what you can do, you need to start from the new orbital. So after the 3d is 4s. So you need to add on these 8 electron from the hydroxide to this, to the 4s and also 4p. And then the overlapping between s and p, it will give you the sp3. Right. So here, this is the 4 ligands in tetrahedral crystal field, where we have the first one here. This is number 1, 2, 3, and also 4, where the coordination number here is 4. Where we have here the sp3 hybrid orbital. And then another one is the square planar geometry. For the square planar geometry, we have here the is actually dsp2 hybrid orbital or new orbital here. So dsp2, this is where we have the overlapping between d, 1 orbital from d, and then s, and also 2 orbital from p orbital. So for example, here we have nickel. This is nickelate. So let's find out calculate the oxidation state for this nickel. So nickel is 28. Okay, so this is -4 equals to -2. This is the x, so x is +2. So this is tetracyanonickelate 2. So the electron configuration for nickel is Ar4s2 3d8, and then we have nickel 2 plus. The electron configuration is Ar3d8. Okay, so but in this case, because the cyanide or the cyano here is actually one of the strong ligand. Okay, for example, let's say one of the strong ligand. What happened here? This complex will have a diamagnetic property and also weakly repelled by magnets. So let's say you draw the 8 electron here. It will become 4. Okay, here it will become like this. In order to become a diamagnetic. Okay, so anything from group 10, nickel, palladium and also platinum, they have tendency to form a diamagnetic compound or complex. So this is what we have, the nickel 2 plus as the 3d8 as I explained to you, and then this nickel react with 4 cyanide, also a ligand. It will form this compound, this complex ion, and then what happened here, these two will excite to this and also combine to form a diamagnetic property. So because we have 4 here, so 4 cyanide, it will give you 4 times 2 electron, so you will have 8 electron. And then you need after that you have 4s and also 4p, and because of this you need to fill up this electron. Okay, start from the d orbital because we have one empty d orbital. You cannot have one electron in order for you to fill up, so you need to have empty d orbital for you to fill up the electrons from the ligand. Okay, from the ligand, because it come because one ligand will give you 2 electrons, so you need to have one orbital, and maximum number for electron to occupy in a orbital is 2. Okay, right, then what happened here, you start to fill up the 8 electron here into the 3d 4s and also 4p. So this is where you get the dsp2. Okay, right. So this is also the similar example, nickel and also cyanide, and this cyanide is actually strong ligand, because strong ligands they have tendency to form what we call diamagnetic compound, and also usually they have low spin complexes. Okay, they have low spin complexes. So this ion or this complex ion, this is what we have discussed before this, and then what happened here, they combine to form a diamagnetic compound, and you need to fill up the 4 cyanide where it gives you the 8 electron, and then because this is full with only one empty d, you need to start from the d. This is where you have the from d, s and also p, where it will give you the dsp2. So this is actually a square planar complex. So the structure for this is nickel with 4 cyanide, and also negative 2. This is the structure for square planar. So that's all for this part 2. And then please don't forget to like, comment and also subscribe my channel. So I'll see you guys in part 3. Bye!